All right, I'm going to go ahead and start with a quick overview of Week 10 problems. So I'm not going to read all the verbiage in the book. I'm basically going to provide some advice for how to do this problem, which is problem 17 in the back of chapter 2 on page 62. So basically, I'm just going to quickly cover this assignment. Before we start, I want to clarify that in the real world, there's many ways to determine if this is a good option. Okay, in the real world, we use software because you can do a lot of modeling and a lot of different types of calculations using different matrices and things like that. So software are a lot more detailed. So what I'm going to provide here is the way I would do it based on the information that they provide. Once again, there's no one way to skin a cat, so to speak. So as long as you get the ideas across and I can see that you understand the basic concepts of what it takes to make the decision, I will give you credit. Obviously, the more detail that you provide, the better the grade. But for the most part, if you provide me a very good understanding of how the decision goes across, I'm usually pretty lenient. So I'm going to start with chapter 2, question 17. So the basic premise is that KLF, this company, has a single warehouse in San Jose, 5 regional warehouses in Atlanta, Boston, Chicago, Dallas, and Los Angeles. Right now, the current customer level is 90%, and they want a desired customer service level of 97%. So if you remember, your customer service level relates directly to things like safety stock, because obviously the higher the customer service level, the more variability you're going to absorb, and as a result, the higher the safety stock. So when you do these kinds of decisions, people go to a centralized system in a bid to reduce safety stock and reduce overall stock costs. So that's the basic premise behind this. Now, in question 17A. Before I go too far, I just want to remind everyone that a lot of the information in all of these questions is provided in the verbiage of the question. So I'm going to pull the stuff out of the question that I'm going to use to answer the question. So in question 17A, they basically state that the demand in the 5 market areas reveals that the demand in the 5 regions is very similar. That is, it's common that if weekly demand in one region is above average, so is the weekly demand in the other region. So in English, in statistics speak, basically that says that if there's variation felt in one of the 5 locations, the same variation is going to be felt in the other 4. So how does this affect the attractiveness of this decision? Now, if you look at this, one of the main draws of centralization is a concept called risk pooling that we talked about early in the class. I want to say like week 3 maybe. And the main theory behind the risk pooling is called aggregation of demand, which basically states, and I will clarify this in case you forgot, that the aggregation of demand will decrease demand across multiple locations as long as each location has a variation that is independent of the others. So basically, if one site has a variation that goes up, another one will go down because they're independent. The whole thing behind aggregation of demand is that if one goes high, another one will go low to absorb the change in variation from another site. What this question is saying is that all of the 5 regions, the variation goes up and down as the same. So the rule of aggregation demand says that demand variations must be independent of each other for risk pooling to be used. So use that information and write to me about how this information affects how risk pooling would be applied to this decision. 17A is fairly simple, straightforward. Now, 17B, this is the nuts and bolts of the question. It provides all this information, which is very important. The order cost per order is $5,500 per order. Okay. Inventory holding cost is $125 per unit. And transportation costs are provided in a chart. I have a spreadsheet here. I just put all the information in the spreadsheet. I'll show you my spreadsheet. I may not share it because when I shared the spreadsheet last time, people got pretty confused. But I do recommend that people do make their own spreadsheets if they have the time, because this allows you to manipulate the data and calculate things. So up here, you can see you have all the demands. I've totaled the demands both per week and per location. So you have it here. So it's cross-tabulated. So, and then ordering cost $5,500, holding cost is $1.25. And the lead time, it says it takes 2 weeks to get material from one place to another. So I'm going to put 2 weeks as your lead time. I don't remember if it says 2 weeks to go to each location, but you know, to go from like manufacturer to the warehouse to the retail outlet. But for this, I'm just going to use 2 weeks. In the real world, it'll be a lot easier to figure out. So transportation cost per unit, I basically made a little chart here, okay, and then to show us what transportation costs would be. So, and then transportation cost per unit per product. This is in a decentralized state. So, like for instance, and this is in the table 2-12. So transportation cost per unit in a I'm going to say centralized system. So centralized system. Okay. So, and this is decentralized system. I'm just going to change it for myself. Sorry, guys. There. So these are very important. I'm going to show you a graph in a minute that's going to show you why this is so important. So it gives us transportation costs. Oh, cancel. We're going to save. So it brings back down to my second display. Get out of the way. So now we're going to compare cost and average inventory levels for the two strategies. So and it asks us for 17D that we should use. Let's see. It tells us compare cost and average inventory levels for the two strategies, assuming that demands occurs according to the historical data. So this is important information. If it occurs according to historical data, if you remember EOQ, economic order quantity, one of the constraints within that model was that the demand was constant and predictable. So in the real world, when I do these kinds of decisions, I always list all the constraints of all the formulas that I use so that management will know the constraints of the model that I use so that they can say, oh, well, the demands won't be constant or steady or predictable. But in this case, we're going to say that they are predictable. So identify which location would be the warehouse. I'm not going to go through and give you all the answers, but I'm going to basically talk through how you can calculate this. So the first thing I always do is I make a graph, make a picture of what I'm trying to do. So right now we have a decentralized system where all of our stuff comes from San Jose and it goes out to Atlanta, Boston, Chicago, Dallas, and Los Angeles. And these numbers here, let me just annotate this. Draw. And these numbers here are the transportation costs from San Jose to Atlanta, Boston, Chicago, Dallas, Los Angeles. These were referred to the inbound transportation costs for each site. Okay, so erase. Whoops. Let me erase this real quick. Oh, clear all drawing. And the numbers back here are the outbound. Okay. Now, and these circles are local markets. So Atlanta has a local market, Boston has a local market, Chicago has a local market, Dallas has a local market. Okay. So, and it's 13 from Los Angeles or Dallas or Chicago to each of their markets. So that's the first model. Now, the second model, I'm going to, okay, let me clear this out real quick. Now, the second model, we're moving to a centralized location. The way it's going to look. Now, this is a little bit confusing. So we have the manufacturer. I did not include that, but the manufacturer would have been over here in this section to San Jose, or San Jose is a manufacturer. Either way. So we have, for example, I just picked Atlanta. You would calculate this for every one of your models, but we basically have manufacturer to Atlanta. So we would use the inbound cost for materials going to Atlanta. In this case, Atlanta would get all of the inventory for all 5 sites. And then at that point, the inventory would be sent off to each of their locations. Now, Atlanta, you know, 13 to their local market, 14 to Boston, 14 to Chicago, 15 to Dallas, 17 to Los Angeles, then 13 out to their local market. So easy enough. So when we calculate the transportation cost, the way that we're going to do this, if you go back to your spreadsheet, in a decentralized output, basically to calculate the transportation costs for each location is fairly simple. All you got to do is take the amount that goes to each site and multiply it by 13 for the, multiply by the inbound, okay? And then multiply by outbound. You can actually just add these for this number here. So for instance, for the Atlanta market, to sell 33 units, you would have 25. So 25 times 33. So you can just make a quick spreadsheet calculation. Basically, you could add these two here and then multiply that number by this number here. And you can go all the way across. You can add up all the costs for the entire period. You would just do the same for each of them. So this is the cost of the current decentralized system, okay? We're basically, we go back to here. We are calculating, let me get my draw pencil out here. We're basically calculating the inventory for Atlanta, which is the 12 and 13, so 25. So each unit is going to have to spend $25 to get to the Atlanta market. For Boston, if I go back to Boston here, whoops, this mouse. So if I go back to Boston, let me erase this. So if I go to Boston, the decentralized system, it's 11.5 plus 13, so it's 24.5. So for Boston, you would basically go 24.5. And the same thing for each site, boom, boom, boom. Then you just add them all up. That's the cost, transportation costs. Okay. So inventory turnover, cost of goods sold per year. You basically add up all the cost of goods. I don't think, is there a unit cost? I don't think they gave you a unit cost in your, yeah, they just give you an order cost, so they don't really tell you what it costs per unit. But so cost of goods sold per year, just, I personally don't do this very much because if the cost of goods isn't provided, then it's kind of hard. So average aggregate inventory value, you basically add up all the inventories and divide it. So I wouldn't worry about this for now. But so basically, so calculate the transportation costs. You just calculate all this. Now, it also says provides information about transportation. Compare cost and average inventory levels. So average inventory levels. Basically, let me clear all drawing. Average inventory levels you can get that. Basically, your average inventory levels would be over here. Basically, you take the total, and you take the average demand. And what I do the standard deviation and the coefficient of variation. Coefficient of variation is important because it provides a very good understanding of the level of variation. Okay, basically is the standard deviation divided by the average demand. So in this case, number 7, which is Los Angeles, has the lowest coefficient of variation of all the locations. Therefore, they have the lowest variation compared to their inventories. Okay, so which is good, because so you can actually make a general statement that Los Angeles has one of the highest inventories, one of the lowest coefficients of variation. Therefore, it'll have the lowest safety stock. So, and when you calculate safety stock, the safety stock calculation, which I have up here, is the Z-score, which is related to your customer service level, which is 1.88 for 97%, times your standard deviation times the square root of your lead time. So you would say square root of 2 times your standard deviation times your safety stock calculation. So I'll get to this in a minute. So the calculate transportation cost, that's fairly simple for the decentralized. Now centralized, remember everything for each site, you will calculate basically the inbound, okay? Actually, so you would start from, you would take your total inventory for each week. Like for instance, the first week's 162. So in this example, 162 units is going to go from, whoops, I need my draw. 162 units are going to go from here to here. Okay, so 162. So you would multiply all of this by 12. I'm assuming this is the input. Let me see. So you would take the inbound cost. Yeah, inbound cost is 12. Okay, so you take 12 times 162. Then at this point, you would basically break off each of the shipments for each one, and multiply each of these calculations. Like for instance, the Boston gets 26. So you'd have 26. Oh, it's a bit of a lag here, sorry. So you would have 26 times basically 27. Then you'd have 14 times 13 plus, times whatever Chicago's is, which is 44. Then Dallas, which is 27 times 28. And then Los Angeles is 32 times 20. And you basically just calculate it. That's transportation costs. So then you add them all up, and you do it for each site, okay? And of course, Atlanta, you have to do Atlanta's times 13. So Atlanta's got 33. You have, so you have 33 here. So 33 times 13. So you basically calculate the shipping costs, transportation costs. And you do this for each site. You can make a spreadsheet that does this fairly quickly. But basically, so then for Atlanta, you would do this. And then the next one, you would put Boston here, and then put the values in as required, and then do the calculations all over again, and keep doing it. As I said, a spreadsheet's the fastest way to do it. If not, you can do it by hand. It would take a little bit longer. But once again, in this assignment, if you don't have the time, which you probably don't, then just talk to the problem, tell me what you're trying to do, tell me the theory behind it, and if you're very close, I will at least give you some credit for it. So as long as I understand that you know what you're doing, I'm okay with everything. Now, so 17B. Like I mentioned before, you calculate standard deviation of demands at each site and total demand. This is where Excel comes in very handy. So in this example, this is straight from the spreadsheet I just showed you. So total demand is 476, which gives you this average, standard deviation. Coefficient of variation is very nice for understanding safety stock. Because later on, we're going to start have to, when we deal with, if I want a full picture of the cost, we need to understand what it's going to cost to hold safety stock. Okay, safety stock is what we use to hedge against variation, and basically we basically have enough safety stock to cover the lead time worth of variation. So you basically do a safety stock calculation for each site, and you would take this 33.9, multiply it by the holding cost per unit per week. And you basically multiply that out and add this to your transportation costs. Obviously, this is going to be a minor part of the costs, but as you notice, the safety stock here is low. So actually, Los Angeles is going to have has the lowest safety stock costs. Now, be careful. A lot of times I see students say, well, it's got the lowest safety stock costs, lowest safety stock, so this is the best place to put it. Well, if transportation costs in Los Angeles is much higher than the other 4 locations, then the transportation costs may overcome the savings you get from having low safety stock. So, and since this problem doesn't tell you how much each unit costs to produce, that's very hard to understand as far as the cost of safety stock. So once again, talk to this in your answer, and you'll be fine. So just make a note that the safety, normally when you make a calculation about centralized versus decentralized, we do safety stock calculations. Now, if you look at this here, we got safety stocks. When we determine the safety stocks from a centralized versus a decentralized location, the decentralized location, each site has to have its own safety stock, okay, because we have regional warehouses. Each regional warehouse has to maintain its own safety stock. So when we look at the safety stock for a decentralized system, we add all of these safety stocks. This is a total of all 5. This is not correct. Yeah, it's definitely wrong. Yeah, I'm sorry. This should be 188.05. So sorry about that. This should be 188. What if I can change it here? 188.0554193. So the decentralized system, as you know, it's 188.05. Now, when we do the centralized location, you basically do one calculation where you take the total, you take the standard deviation of this, and your lead time, and as you can see, the safety stock for centralized location is roughly half of what is needed for a decentralized location. So you're saving that much worth of inventory. Once again, the problem doesn't give you an inventory cost, so just speak to this information and just say, hey, transportation costs are this based upon your previous calculations. Your inventory would be this much less in a centralized versus a decentralized system, resulting in this much savings in inventory. Okay. So question 17C is very interesting. What they do is they say, okay, we're going to use UPS ground. What it does, it reduces the lead time to 0.5 weeks and increase transportation costs by 50%. Is this still a good strategy? So let's look at safety stock calculation. When we look at safety stock calculation, the lead time, the square root of the lead time is directly affects safety stock. So basically what you would do is recalculate the safety stock using 0.5 instead of 2. And you're going to see a pretty good drop in the amount of safety stock that you need. Now, unfortunately, your transportation costs will increase 50%. So now, in this example, I just did a quick calculation of safety stock. In the decentralized, it went from 188 to 94. And in the centralized, it went from 99 to 49. So it basically cut it in half. So you say, okay, well, we save a lot of money on safety stock because we can replenish our stocks faster. So you need less safety stock to hedge against lead time and variation. Okay, but now we got to look at the transportation costs. Do the calculation and say, okay, our transportation, just basically all you got to do, just calculate transportation costs. Basically take the previous number, what you can do is multiply it by 1.5. And that gives you the new transportation costs. And then just talk to the new calculations. And I just added this. You can make a spreadsheet that looks a lot like this, where you basically do the calculations as I just mentioned. You do it for each site if it's decentralized, right? Atlanta, plus the costs. Now, don't use these values because these are from a different sample. Basically, what you would do is basically do Atlanta, the cost of moving stuff. If Atlanta was the decentralized hub, I'm sorry, this is the decentralized current calculations, basically, as I showed you earlier. Then if you centralize it, basically you would do this as if Atlanta was the hub. So inbound times, right here, okay. Inbound transportation cost of total inventory. So you take a total inventory multiplied by your inbound cost. And then you add the cost of your total inventory minus local demand. And then, so basically you subtract what, let me explain it from here instead. It might be easier. So basically what you do is like I said before, you multiply all of the, let me draw. You multiply all of the inventory for each week by this number here. Okay, that's the inbound. Then you do the outbound for each site. So at Atlanta's inventory times 13. Boston's inventory times 27. Chicago's inventory times 27. Chicago's inventory times 28. LA's inventory by 30. And then rinse and repeat. So next time you put Boston here, inbound for Boston, then 13 to the local market for what they have for their local, then multiply it by, Atlanta, Chicago, Dallas, Los Angeles. And you could even do this, you probably could just use your totals, unless you want to do it for each week. You could probably just, since you want a total, well, sorry, let me clear this out. You probably could, clear all. You probably could just take these numbers here, total demand, and just multiply these numbers by the various locations, okay? Just gave you a quick calculation of what it would cost. And then talk to your numbers. Whoops, cancel. Then just talk to your numbers. That's all you gotta do. All right, so I quickly talked about 17A, 17B, 17C. Since this is the last part of the class and you basically got until today to get it done, if you can't do the calculations, if you can't do the spreadsheet, talk through all this information. Basically go through what I said with the transportation cost per location, your safety stock, your inventory values, adding the safety stock into your inventories based on the calculations that I did earlier. And basically talk to the numbers. You don't have a cost for each unit, so you won't have total cost, but you'll have costs for transportation. You have costs for ordering costs. Now, ordering costs, if you want to go into ordering costs, all you got to do is go to your economic order. I'll put it up here, economic order quantity model, and basically calculate your optimum order quantity that we talked about early in the class. And then just divide the inventory by this number. That gives you the number of orders that you will need for each location. Like for instance, let's say the EOQ for, where's my list of, did I have that in here? Okay. I don't. So let's say that our EOQ, I'm not going to calculate it really fast, but let's say your EOQ is 50. So based upon an EOQ of 50, your demand for Atlanta would be roughly 10. So you go 10 times your order cost. It would cost you $55,500 for ordering stock for Atlanta. And do the same for Boston. So calculate EOQ. You can even do EOQ at the warehouse. Just take your totals. Take your total numbers. 2661. And put this in. Okay, if I go back to EOQ, I'm going to try not to make this too messy for you so you can understand it. So go back to EOQ. 2 times your demand. For your demand, use 2661. Ordering cost per purchase order is $55.50. And you get that from your from the textbook. The textbook gives that to you. So order cost, in my spreadsheet, it's right over here. $55.50. Okay. And then H is your carrying cost per unit. Carrying cost per unit is your holding cost. Same thing. Holding cost, carrying cost, same thing. So your holding cost 1.25. So put all those numbers in there, and you have an EOQ. Divide your total by your EOQ. Tells you how many orders you need to order, and then multiply that number by 55.50, and that gives you your ordering cost. So you can add that on top. As much detail, the more detail, the better, obviously. So this was a quick synopsis of how to do this problem. I'm going to try to post it before I go to bed right now so that everyone has access to it to get their problem done. If I can take the assignments, if you're past Sunday and you want to get it to me, you have until pretty much, I have to have the grades in by Tuesday, so get the stuff in on Tuesday so I can get it graded for you. May not be able to give you feedback, but at least I can get it graded for you. So feel free to send me any emails while I'm asleep. I will answer them when I wake up. So thank you very much, and good luck on this assignment.